Vishal. That's all the time we have.
Okay.
Next, I'd like to invite Montana Bilger, co-founder of Deep Space Biology.
Hi, I'm Montana Bilger, the CEO and one of the 3 co-founders of Deep Space Biology. I hope you're strapped in because this presentation is going to be out of this world. At Deep Space Biology, we develop innovative solutions for safe space exploration. With the increased interest of going to space with space travel and space tourism, there still remains one big problem. Space is pretty dangerous. The human biological limit is 12.5 days in deep space before the onset of serious biological changes. This limit is not enough to safely navigate the planned Moon and Mars missions within the next 10 years. Before we can solve the problem of biology limitations, however, we first have to understand the problem at a deep level. This is where the field of space biology comes in. Unfortunately, current space biology methods are expensive, time-consuming, and struggle to aggregate crucial siloed data. While attending the Masters of Analytics program at Georgia Tech, the other co-founders and I saw this problem in space biology, and working on a group project, we wanted to fix it. So we did what any logical person would do. We spam emailed a bunch of NASA scientists at GeneLab. We ended up getting an automatic out-of-office email reply with a Zoom link in it. So we invited ourselves to a NASA AI for Life in Space committee meeting where we pitched our project, and for the last 15 months, we've been working side by side with NASA GeneLab to help fill the gaps in space biology. How do we fill those gaps exactly, though? Well, we've developed a new AI-driven platform called Mouse, which can reduce biology research times from years to minutes and can save organizations millions of dollars a year. You might be asking yourself, what's going on with this flashing sphere on the screen? Well, that's a great question. This is our platform in action, modeling all of the biological craziness happening at the gene level in space. As I mentioned earlier, before we can start to solve the biology limitation of space, we first have to understand what's going on. And this is where Mouse shines. By connecting siloed biological data and applying proprietary machine learning algorithms, Mouse can accurately predict biological changes in space and help save human lives in space. We have a functioning MVP that's been tested with numerous NASA GeneLab experiments. Essentially, our platform can take any stressor or exposure and produce an expected outcome. It has applications for not only deep space travel, but low Earth orbit missions, airline travel, toxicological and pharmacological applications as well, among many others. Mouse also has incredible traction so far, with amazing partners like NASA GeneLab, Georgia Tech, Neo4j, and Voxiva, among others listed here. But you don't care just about the product, though. You care about the team behind the product. Do they have the passion, the grit, and the skill set to deliver? Our experienced and highly qualified team most definitely does. We all have masters in analytics from Georgia Tech. I myself have a bachelor's in physics from West Point. I'm a US Army veteran and have a US Army Space Enabler certification. I've worked as a data scientist at Nike and also a Series E funded tech startup. Our chief bioinformatics officer, Michael, has a PhD from Leiden University in molecular biology. He was a science research specialist at Harvard Medical School. He's won many awards in aging, age-related diseases, and toxicology. He co-developed the first transgenic mouse model for mutation analysis, and he started his own biology company aimed at validating and developing innovative solutions for in vitro and in vivo mutagenesis testing and toxicological risk assessment. It's a mouthful. And lastly, our COO, Guillermo. He has a master's in analytics as well. He has a bachelor's in chemistry. He's actually a member of the NASA AI for Life in Space Committee, the same one that we barged in on 15 months ago. And he co-founded his own analytics company the year 2000 and has deployed analytics health solutions in over 19 countries. We believe in safe space exploration. So we develop innovative AI solutions to make it happen. We're currently looking for partners who want to shoot for the moon and be among the stars. Thank you.
Any questions from the judges?
Hi, thank you for the nice presentation. Just one question regarding to the AI approach. So where do you get like all of this data from? So you need like a data set, right, to build the platform. So what is your reference, data?
It's from NASA G Lab.
Okay.
We've been meeting with them on a bi-weekly basis for the last 15 months, co-developing this platform.
And how can you validate the data? When you get the algorithm, how you can validate?
Yeah, so in the combination of not only the actual experiments that they've performed in space with the real reactions, we also have a knowledge graph that consolidates all of the current medical publications out there to validate the results.
Can you elaborate on your commercialization plan?
Yes, so as a biology research tool, currently NASA is our big target because we have already a really good relationship with them, but it doesn't just stop here. Because our platform can be changed to take any external stressor like radiation, microgravity, you name it, and produce an expected outcome. It can be applied to medicines ingested by the body, any sort of exposure that anyone can have. So it's not just space biology, even though there's a direct correlation right now to space biology.
So I know you're focused on Gene Lab and have a good relationship there. There are actually a number of other institutions that are doing various experiments in space that may be of interest. Do you have a plan for engaging other sources of data? Platforms like yours are most robust when you have many, many different sources that can all build upon themselves. Do you have a plan for that in the future?
Yes, we do. So right now, because the Gene Lab data is easily accessible, that's what we've built it on, but we have a plan to incorporate as much data as possible. And because our platform is modular, you can impute new data and it can give you updated results from that.
Thank you, Montana. That's all the time
Thank
we've
you.
got. Next, we have Gabriel Plinslon.